Welcome to Chapter 2. In this chapter, we'll be talking about soft body physics. We'll explore how to make objects seem like soft, malleable materials with realistic deformations. Let's go ahead and jump in. Alright, so now we know all about rigid body physics. We know that if we click on a sphere, we add a rigid body, and then we click on our plane below, we add a rigid body type passive, and we press play. The sphere will fall onto the plane. But sometimes that can get a little boring, and sometimes we want to have a little bit more of an option as to what happens to the sphere when it falls. Well, that is where our next physics property comes in. It is called soft body physics, and it's exactly as the name implies. Soft body meaning that it is a softer surface, it can crumble, it can fold, it can bounce, and there's a lot we can do with this, and it's really fun to play around with these settings. So all we have to do is, with our object selected, we add a soft body physics, all right? And if we press play, let's just see what happens. Nothing happens. That's because there's a couple of settings we need to adjust, and there's a couple of things you need to remember that are a little bit different than rigid bodies. For example, if we click on this plane, right now it's a rigid body. We actually don't need that. In fact, I'm going to get rid of rigid body, and I'm going to add something called collision. Unfortunately, soft body physics don't really act the same way that rigid body physics act. They still are physically simulated in the 3D world, but we need a collision for this to actually run into. So let's go ahead and press play, and still nothing really happens. And that's because we have a couple of settings that are enabled. First of all, this goal setting, I'm going to go ahead and uncheck that. We don't want that setting, and we're really not going to talk about it because it's an annoying setting. So let me go ahead and press play here, and you'll see that our sphere crumbles, which is great. That means our soft body physics are working. But this isn't exactly realistic, right? Objects don't just crumble in real life. Let's go ahead and adjust some settings here. First of all, on the right, under the edges category, you'll see there's something called bending. This is exactly as it's implied. How much does the object actually bend? I'm going to actually set that to 1, and I'm going to go ahead and press play. And now you can see we get a slightly different result, but our object is kind of still intact and it looks kind of weird. Let's go ahead and adjust a few other settings. I promise you, if you mess with these settings enough, you'll spend hours trying to perfect them, but I'll give you a couple good ones right now. For our pull, I'm going to go ahead and set that to 0.8, and for our push, I'll set that to around 0.7. Let's go ahead and see what we have now. That's a little bit better. Let's set these values a little bit higher at 0.9 each. All right, let me go ahead and play this back. That's a little bit more realistic. Now look at how this sort of acts like almost like jelly. Now you'll notice as I played this back, I'll just adjust one of these settings, up here you'll see a lot of red numbers. That means that Blender's having a really hard time calculating what's actually going on with our soft body physics. Right? And if we back this up and play it one more time, you can see just how everything interacts. Now it's still a little bit glitchy, and I'm going to show you how to actually add some interesting details to this physics simulation. Now, this might slow your computer down just a little bit, but it'll give us a lot better of a realistic physics simulation. We're going to go to our modifiers tab. We're going to add a modifier, and we're going to generate a subdivision surface. Now, what this is going to do is it's going to allow us to right-click and shade auto smooth. And when this actually drops, let's go ahead and see what this looks like. Much smoother. And the reason it's much smoother is because we're actually adding more geometry to our physics simulation. And this looks great. Now, what I want to do is I want to test a couple of things out here. I'm actually going to rotate. I'm going to go to my side view. I'm going to rotate our platform a little bit here. And I'm going to duplicate it, rotate it again, and we should have something that looks kind of like this. I want to see what happens as our sphere falls now. It should fall right off, and it should run into the next thing. Now what's really cool is this is kind of like a fun little obstacle course that we've created for our jelly ball here. Now that we have this is where we can get into baking again. And remember, all baking is telling Blender, hey, can you please remember what happens here so I can play back smoothly? Let me go ahead and click on my sphere. Let me go over to my soft body physics. You'll see it says cache right here. Go ahead and open that up. Now I'm just going to bake out to frame 100, so I'll make my end frame 100. I'll click on bake, and as you can see, it's going through the bake right now. It takes a little bit longer with soft body physics. Now if we play this back, we should get some nice smooth playback. And if you're still not getting smooth playback, remember this stops at frame 100. If you're not getting smooth playback, you can disable subdivision for the viewport by clicking this little icon that looks like a display. And you can see it doesn't look as good, but you can get much smoother playback. And we are getting 25 frames a second playback up here, which is great. And our physics simulation is already calculated. Now let's say we wanted a little bit more. Go back to our bake area in our physics properties, delete your bake, all right? And what I'm going to do is I'm going to duplicate this, okay? Because I want to have a couple of these that interact with each other. Let's go ahead and play this back and see what we get. Interesting. As you can see, we can have multiple soft body physics interacting. Just remember, if you want to create more obstacles, such as a cube, let's say we want this cube to kind of interfere with our falling physics simulation here. I'm going to delete this for simplicity purposes. Our cube does not have to be a rigid body. In fact, if it is a passive rigid body, this should just go right through our cube, and it does. And the reason for that is, remember, we need this to be a collision. So I'm going to go ahead and enable collision. Now let's watch what happens. As you can see, now it kind of runs into our cube. And I don't know if it's going to be able to get past it. No, it's not. Now, the other thing is we didn't bake this out very far. So if we wanted to, we could go back and bake this out. But right now, we are running into our cube because our cube is a collision and our sphere is a soft body. So there's a lot of experimenting that you guys can do with this, and I definitely want you guys to check this out. There's a lot of settings. I'm not going to go over all of them because there is just way too many, and this is a beginner level course for physics. But if you open up all of these different collision options and edges, you can get a lot of different effects that could emulate a lot of real life materials. And if you look up the properties of these materials, more than likely, they might have similar settings, well, similar real life structures that you can emulate. And you can find out how much does a rubber band bend? How much does a basketball bounce? These are different options that you can select within Blender.